Alright, in this video we're going to do a fun comparison between PFlow and thinking particles. When we create a PFlow system, it automatically sets up that first event with quite a few parameters for us. And one of the other things involved in creating a PFlow is actually specifying the dimensions of the PF source. So we'll take that into consideration when we make TP. And also that PF source, by default, when we create it in the top view, that axis direction points down. That'll be a little difference that we'll take a look at too. So we'll create our TP system there, open up the TP UI. Let's take a look at the PFlow UI real quick. We've got the top level container, and then we have that first event where we create some particles during a time interval of 0 to 30. It's creating 200 of those particles with subframe sampling. Then we assign the position of those particles onto the volume of this emitter. And then we issue some speed to them in a specific direction. And finally there's rotation, which is kind of alignment. And then there's shape assignment of a tetra with a size. And then finally display parameters, which we don't really have in TP except for on the master dynamic, where we control how those are displayed. One of the things we want to do with PFlow, though, right off the bat, is set the display type to be geometry so that we actually get to see the shapes that we're dealing with. And let's go ahead and walk through this now. Let's recreate this birth event from 0 to 30, birth of 200. We're going to create a dynamic set, and we're just going to call this PFlow default. And we need a time interval condition to control that 0 to 30 timing. So 0 to 30. And what we'll do then is we have to think, how are we going to create these particles? Well, we want them assigned on a shape. So that's going to be one step that TP needs, is it's going to need a shape to operate with. In this case, we'll just use a plane. Alright, now we've got that plane there. Let's go ahead and we're going to need a node in order to pick that object. And this is going to be a little bit different than PFlow, where PFlow, when you create that PF source, it automatically creates that for you. There are ways that you could do that in thinking particles, but for now we're just going to go ahead and use a simple plane object. We're going to need to get some surface position information about that plane so that we can birth particles on the face. And we'll just adjust the random seed right now while we're here. And let's go ahead and add the generator. We're going to use a position born, and we need to control we're going to add the surface position's output position and connect that to the position input of the position born, so that these particles who are being created reference this position information from the node. Alright, so and then we want to control position born to only be active and emit particles during that interval. Just tidy that up a little bit. Okay, let's go ahead and see what we get so far. We get some thinking particles here, and we see our PFlow particles are moving rather fast. If we take a look at their speed value, it's at 300, and our thinking particles are moving based on the normals of this object that we have. So just for comparison, we're going to just tell PFlow to reverse its direction, point it up there. And so in thinking particles, obviously we need these particles to be a little bit faster, and let's go ahead and turn edit on the fly off so we get real-time updates, and this will help us match those properties a little better. If we just set that, not the lifespan, but the speed to 300, and we're going to turn off the angle, the direction variation. There's no explicit lifespan specified for these particles here in PFlow, whereas in TP, by default, it's set to 30. We're just going to go ahead and set that to a rather large number. And we'll notice that if we set this count to 200, obviously we only get one particle here. The reason for that is probably because this time interval is looking only at a certain window, and TP is, I believe when it uses this count, it's actually evaluating, it's not taking this into account, basically. So what we're going to do is we're just going to kind of cheat that and get out here to frame, say, 32 when all the particles have been born. And we're just going to adjust our rate until they match. So we'll watch our count number up here in the top. So a total of 100 particles. The reason we only set that to 100 there is because actually when we look at PFlow and take a look at its particle counts, we're only getting 100 particles within this time span instead of the 200 that we specified there. So anyway, right now we have these numbers matching 100 TP particles. Let's go ahead and work on the shape information. Let's go ahead and assign a shape, standard shape, to those particles. And we're going to go ahead and use a tetra. And we need to increase the size. If we set it to 10, let's see what we get. Is our display set properly? We have to turn on show mesh, and we'll force that setting. Now we get some pretty drastic differences. The tetras in PFlow are programmed a little differently than thinking particles. You can see the ones in TP are much smaller and thinner. So we're going to go ahead and make some adjustments to compensate for that. And you'll also notice that the scaling of the thinking particles tetra object, actually not the scale, but just the overall shape is different. So we're going to go ahead and modify the scale in order to make them appear like PFlow particles. And the way we're going to do that is just we're going to reduce the Z scale for all those particles. And it looks like they still need to be a little bit bigger. And a little, maybe a little less. Z scale. Okay, so one of the other things then is our alignment. The PFlow particles come out with a random rotation, and that's not spin. They're not spinning. They are just kind of aligned in a random fashion. So for that, in TP, we're going to use the alignment operator, connect that to those particles. By default, it comes out as random. That's great. So now we'll see that our TP particles are also kind of randomly rotated there. And for the most part, we've pretty much matched what we have in PFlow. We've got the same number of particles, we have kind of the same properties being created, and so it's just kind of a fun experiment to look at. Well, PFlow automatically kind of gives us all this, even though we do have to create that size emitter. In TP, we're going to need an emitter to emit off of, and that, at least in this case, it can be done just programmatically, probably with iterator or a TD tool. However, in this case, it's easiest and very fast just to go ahead and pick a node that will act like that. And then finally, we'll go ahead and save out this black box as PFlow default. We'll save it here in the tutorials directory, so you'll have access to that. And our particle groups after loading, well, we're really just using the all group. Let's just go ahead and say use existing. And so now let's take a look. If we were to delete TP and delete that node that we were using, let's create a TP again, and let's go ahead and we'll create the node that we're going to need to emit off of, create a dynamic set, load our black box inside that dynamic set, tutorials, PFlow default, take the node helper there, pick the plane, and there we have those particles being created. Now by default, when we create thinking particles, ours is set up so that it has certain display properties. You will want to go ahead and modify those to match that as well. Okay, so that's just kind of a fun little comparison, seeing how what's involved in the existing PFlow system and how to create that back in thinking particles.